Yeah, hi, very good evening, everybody. And I'm so sorry I'm a little bit late. So let me take the questions which are come already. Uh, Physics Halt is telling, sir, thank you very much for the session. I could not be able to watch to complete, but try to watch uploaded one. Okay, thank you. And there's one question: what are the main prerequisites to become a theoretical physics, which you think is most important if anyone wants to become by your experience? So, Physics Salt, are you there? If you can just ping me with a hi, and you can tell me if you're listening to me or if you're not, that would be great. Uh, the thing is that to become a theoretical physicist, to be very honest, there is nothing as such. There is a rule that you become a theoretical physicist. Oh, Vishal, you are there. Okay, hi Vishal. Very good evening. Okay, so I was just answering, I think, your question. You came in the name of Physics Salt, right? If you can tell me yes or no. What are the main prerequisites of a theoretical physicist? Good evening. Yeah, good evening. See, the thing is that, as far as my experience goes, whether you will become a theoretical physicist or an experimental physicist, or you become a nuclear physicist, etc., to be very honest with you, we cannot tell like that. I mean to say, it is very difficult to, in order to tell that how will you become a theoretical physicist. Okay. Okay. Yeah. Photon classes. Good evening, sir. Yeah, Photon. Very good evening. Okay, let me answer one by one. I will answer all the questions today. That is the reason I have come. So, whether you become a theoretical physicist or an experimental physicist, that is very difficult to tell. So, the first thing is that my type board is not working. Okay, fine. No. Okay, you are here. Okay, fine. So, first of all, if you are taking up a subject which is very much theoretical, and I would say not much too much experimental. For example, cosmology can be one way of theoretical physics. For example, high energy physics can also become. I was talking to Dr. Debanjan Bose. He is coming on 26. I will announce it. He is basically again a theoretical physicist at the Satyan Bose National Institute in Calcutta. So he was also telling that, Shounak, the thing is that whether you become a theoretical physicist or not, that depends upon the course of action that you are taking. Now, say for example, you have done your masters, you're doing your PhD. Now, the whatever the way that you are taking up, that actually depends whether you become a theoretical physicist or not. Number one. So, what is the thing that you're taking? Are you taking up, say for example, typically a kind of a study which is very theoretical in nature, or which has got an experiment? For example, particle physics, that lady who would be coming on 3rd of December directly from Fermi Lab. I think that will be a good opportunity for all of you to ask that, Madam, how would I make a career in theoretical physics? So she is working in Fermi Lab, and she is basically a experimental physicist. That means all the particles and whatever things are moving, they have got an experimental physics. Okay, what amount of mathematics I need? Basically, I want to ask. Okay, so, okay, Prasad, just wait. I will answer all the question. First of all, to be very honest with you, Vishal, and others who are listening to me, in order to become a theoretical physicist, you need much more of an imagination rather than mathematics. I will be very honest with you. The reason is that theory is something which is more, I would say, what I would say, more of an imagination, that what is going around the black hole, what is growing around what happened during the Big Bang. Okay, so it is actually more of an imaginative power, that from 2023 you are moving back maybe 1 lakh or maybe 100 million years back from today. Now, see, the thing is that until you imagine that during that time the singularity was there, after that there was a burst, and there was a big bang. What could be the possible temperature of the stars? How could the black holes emerge? How would the chemistry of the stars would work? What would have been the temperature during that time? After millions of years, the universe cooled down. So you see, if you listen to Dr. Roger Penrose, who is one of the greatest theoretical physicists of our time, what you will listen is that more of an imagination. Yes, imagination is more important than knowledge. Very good. This is Einstein's quotation. So, imagination is typically important. Number one. Now, the next thing that I would like to tell, typically in case of a theoretical physicist, is that mathematics I will come. What is the mathematics that you need? But more than that, what is important is that how much you can, how would I tell, how much you can backtrack a particular event. Also, that also comes imagination, and you count the probability. So the first thing, Vishal and others, those who want to become, I will make a complete video, and if I can, probably I will ask some theoretical physicists to come online and let us have a session. First thing that would be required is probability, statistical probability, and you need to learn a lot about probability. Now you might say, why, sir? Why not linear algebra, differential geometry, A, B, C, D? Because see, most important thing is that yes, he is mostly geometrical viewpoint. Yes, because the universe which is today, for example, 2003, we are talking on 10th of November. Now I am tracing back to such and such millions of years back. Then all those matters, atoms, molecules, etc., all those things would basically, we really don't know. We really don't know what happened. That means we are making an estimation. What could have been the start? Say, for example, I was talking to one person today. See, he was telling that, see, today what we see as a North Star, you go upstairs on the roof and you put up a telescope, small telescope, you will see a North Star. Okay. Now, this North Star which you're seeing today on 10th of November 2023, the same North Star was not there 1,50,000 years earlier. Now, the question is that why it is so? Why it is so? Because the North Star, which we today see as North Star, the Earth's axis has changed, right? Due to global warming, etc. Whatever, the Earth's axis has changed. So if the axis is changing, the North Star, which we are seeing it here today, will change also, isn't it? That means you need to have a very strong mathematical intuition in terms of probability. So you can all do what is an estimation, not an exact calculation. So first of all would be probability, very strong statistics and statistical mechanics. I would say please learn a lot about statistical mechanics. And what Vishal told right now, which is right on the screen, that he is mostly the geometrical viewpoint physicist. Why Roger Penrose is a geometrical viewpoint? Because you cannot measure the atoms, molecules, temperature, stars, anything 1,50,000, 2 lakh, or maybe millions of years back. You cannot do that, isn't it? Why? Because everything has changed. What you can do is that what we do in quantum mechanics, we can only take a probability, we can only take an estimation. So there it might would have happened there. That means whatever the mathematics that you require in quantum mechanics, you have to thoroughly master that. That means statistics, that means probability, differential calculus, integral calculus, and very much about the geometry. I would also say that if you want to become a theoretical physicist in whatever area, be it particle physics, be it cosmology, be it whatever, you also need to understand a little bit more about cosmology on a larger scale. Now, you will tell me, sir, I am learning material physics or particle physics. What has cosmology to do with that? But my answer would be, my dear, the cosmology on a larger scale actually gives again the probability of the entire universe. Until and unless you understand the probability of the universe that was 1 million or 10 million years ago, how will you estimate that this cosmic background radiation or this supermassive black hole was during that time? Are you getting my point, Vishal? So the first and foremost thing that you need to do and understand is probability, probability distribution function, statistical mechanics, a lot of chemistry. Why? Because all the atoms and molecules during that time, how it was, the temperature, all those things, even neutrinos. You saw Dr. Jessica told the neutrinos are not massless, they have a mass. And I told in the last class of quantum field theory that standard model tells that neutrinos do not have mass. That means there is a discrepancy. Now, how the theoretical physicists calculated the neutrinos mass? If there is no probability, if there is no geometric or intuitional understanding, are you getting my point? So whatever is required in terms of, I can tell you in a summary, whatever is required in terms of probability, estimation, statistical mechanics, statistical chemistry, in fact, even more about the chemistry and cosmology, all those things will be required, whatever amount of, whatever the area that you are taking. So that is something which answers your question. There are other people who are watching also. I will come to that. Good evening, sir. I am studying in 12th. I'm a graduate student. And I'm a graduate student, and what are I going to do in research in physics? Okay, who is this? Prasad. Prasad, you need to tell me a little bit more that what actually you are meaning by going to do research. Research can be many ways. Research can be in various areas: pure mathematics, pure physics, theoretical physics. So put up your comment over here a little bit more clear, because I cannot understand what are you telling. Okay, Sashank is there. Sashank is telling what is theory of equations and why we study, and how theory of everything will be useful in learning other branches of mechanics. Okay, so this is a very common question, Sashank. See, the thing is that theory of everything is something we are still searching about. Okay, it is nothing that we have got till now. If you remember, Dr. Professor Shayantan Chaudhary also told the theory of everything is something which we really do not know. Yes, but your question is very valid. What is the theory of equations we study, and how? So, if, say, for example, today we don't know how to go to moon. Say, for example, Chandrayaan has not been launched, for example. Now, if we are making a Chandrayaan, a device which will go, for example, it will go and soft land on the moon. Now, you see, during this, our entire search and study of making a Chandrayaan, we learned a lot of new technology. Not only space technology, camera, lens, a lot of things, topology, lot of things. So, if we are really searching towards the theory of everything, then we will learn a lot of mathematics, lot of physics, lot of astronomy, lot of cosmology, which will help in other areas. Maybe we devise a lens so that Chandrayaan can take beautiful pictures of the on the surface of the moon, and this photographic, I would say, technology can be used in the iPhone 13 or 14. So it can be betterment for our. So theory of everything is a big grand search. We are not getting it, but it is good that we are searching so that the other technologies are improving and it is coming to very useful use. Say, for example, I was just making a very wonderful video of quantum field theory. I don't know whether you people really watch it or not. This is very simple. I will just launch it by Saturday and Sunday. Why do we use Lagrangian in quantum field theory? Now, every theory has a limitation. For example, Sashank has asked that how theory of everything will be useful. Now, if I ask you, Sashank, tell me, why are we using Lagrangian and why we are not using Newton's laws of motion? Why we are using Euler Lagrange? That means every theory has a limitation, and from that limitation we take forward. We are taking Lagrangian due to a. You will see that video, you will really enjoy. I made this very simple calculations, and you will really enjoy. So the thing is that, so it will take us to further learning. I hope this makes it clear. Okay, Vikram Vishal Storywala has a, sir, I have a new take on relativity and quantum physics, a new interpretation, but I am not a PhD. I'm just a physics graduate. What should I do? Okay, so Vikram Vishal, if you are already got something really very good, the first step that I would like to tell you is that create a profile in ResearchGate. Okay, create a profile in ResearchGate. Even if you're not a PhD, you will get a unique opportunity to network with a lot of good people. Sorry, I am there not in ResearchGate. Okay. So first of all, create a profile in ResearchGate and try to network with those people, trusted people. I'm telling you, Vikram, because there are a lot of people who will try to snatch out the original idea from you and make their own paper. These type of things happen. I am into research. I am networking with a lot of good mathematician and scientists. I know this story. I cannot tell it right in YouTube over here, but I'm so sorry. So try to get hold of a right person who has got a right. So you can contact this person, Professor Shantan. I can give you his number. He's a genuine person. So try to get in for a genuine person who actually has got curiosity and understanding in terms of, I would say, who really values your theory. So typically what happens is that this those people like you who have not got a PhD, you will also get a unique opportunity to float over your quantum physics and whatever the new interpretation you have. So first of all, until and unless you create a good profile in ResearchGate, you won't be getting a very good opportunity to talk, very good opportunity to network. And remember, there are a lot of false people also around. So be very aware, copyright, protect your original thesis so that nobody can steal it. Are you getting my point, Vikram? If you can just put me a yes or no, I would be happy. Right. Okay. Okay. What else? Okay, Rakesh has got Earth wobbles precess even though it is spinning, which is like a spinning top which wobbles. Yes, process while spinning, hence not pull today's different. Absolutely, Rakesh is very right in telling this. Rakesh is very right. So the this process actually what is not pull today is very different from fear. This is a very valid point. Very valid points. Thanks, sir. It means a lot. Can I share it with you? You can share it with me. You can email me. But to be very honest, see, I'm a very clear cut person. Yesterday, I don't know who was the person. I felt a little bit bad. Somebody came in the live when I was doing this interview question and told me, sir, told that, sir, your contents are very good, but nobody supports you. Okay, so I told that if somebody is not supporting me, then how am I getting so many subscribers? How I am getting so many participation in my general theory of relativity? Why people are sharing my certificates? So what I am trying to tell Vikram is that this is same with me at my age when I'm crossing 41, 42 years of age. Still, people will be criticizing me. You understand? So there will be people who will be criticizing you. If you want to send me, you can send it to me. I am throughout the day so busy, I can just have a look and I can give you my suggestion. But again, I will be very honest with you. I believe honesty is the best policy. I am not the right person who can float this or take this forward. Prasad Ramanand is saying, no, sir, we support you. Yeah. Thank you, Prasad. No, these criticisms will be there. There was one person who was asking me, you ignorant, this is not the alphabet, you that video which is very popular. So let them say ignorant. If somebody tells you as a ignorant, will you become an ignorant person? Okay. So the question, Vikram, what I'm telling is that you can send it to me, but the question is that uh, you need to find the right person, an honest professor who can guide you. So the thing is that I can check on the mathematical part, that I can check, but a proper person who will say, okay, here is Vikram Vishal, he's a nice person, he has got a new theory, and maybe suggest that, okay, Vikram, you're not going in the right way. So first of all, create a LinkedIn and a ResearchGate profile. Try to get in touch with good people, real, genuine people. Don't rush immediately. You are emotional, young boys and girls. So don't be emotional and just try, because there are a lot of, I cannot tell you again. I'm telling, contact me later. Okay, Vikram. There are a lot of inside stories. I'm so sorry. These are very, I would say, very bitter experiences. I also know. So people will steal. People will change your variable in such a way you won't be able to understand. I'm telling you, there are smarter people than you and me around the world who are ready to fool you. A very good, genuine idea will immediately be stolen. I don't want to say further. I hope you understand, Vikram. Okay. Animesh Shah is telling, hi sir, can you tell the full mathematical background to start classical mechanics to start with a book like Goldstein? Okay, this is a very good question. I'm very thankful to Animesh for asking this question, because most of the students nowadays, they ignore classical mechanics. They think themselves to be Roger Penrose or Leonard Susskind and Gilbert Strang, who can do a lot of quick mathematics. Okay, so full mathematical background to start classical mechanics. Okay, Animesh, what I would request you, I am putting you my email ID over here. Contact dot physics for students at gmail.com. Okay, wait, be there. Okay, don't go away anywhere. I'm just opening my ebook section. I will tell you a very good Russian book. Just be there on the line. Where is my? Uh, just a second. My laptop is full of all those equations. I get lost. Okay, hold on. You are talking of classical mechanics, right? Classical mechanics. Huh. Okay, just hold on. Got the name of the book. Yeah, okay, if I copy and paste it, you will get it here. Let me try. Let me try. No. Just hold on. Why I cannot copy this? Okay, okay, Animesh, you do one thing. You send me an email or a WhatsApp or whatever. The name of the book is Fundamentals of Physics, Volume 1, Motion and Forces. This is written by B.M. Yavorsky and A.A. Pinsky. This is a Russian book of 544 pages, right, Animesh? So just send me an email or WhatsApp me, you will get it. I will send you the name. This is the very first book. Okay, it is very first book, and I can see this. So it starts with what? Velocity, inertia. Very good. Yeah, this would be an ideal book for you. This would be an ideal book for you. So Animesh, my request to you would be contact me after this session. Okay, in email I will send you the name, and uh, you can I will mail you the name. Okay. Okay. Indrajit Das, sir, I am a 12th pass student. I have interest, sorry, in both in physics and aerospace engineering. What route should I choose? Physics and aerospace engineering. Okay. First of all, Indrajit, if you don't take me wrong, can I ask you, where do you stay? Which part of India do you stay? Or are you staying outside India? If you can just put it in the chat box, there's a reason for that. I'm coming to you, Prasad. Don't worry, I'm there. I'm happy that people are listening. I don't know when I take classes, why you people are not there. Do you find my classes boring, quantum field theory, or it is difficult? Nobody is there when I'm teaching quantum field theory and Lagrangian. Okay, West Bengal. Okay, 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 fine. So either you can see if you want to take aerospace engineering or physics. I would say, Indrajit, you should take aerospace engineering. Now this depends on two factors. If you are telling you have interest both in physics. Now physics is what? Huge. What area of physics? Particle physics, cosmology, experimental physics, quantum computing. You have to specify me. Right. Okay. So busy. Rai is telling no sir time issue. So physics means what? You have to tell me that. Now, if you are taking pure physics, especially if you are in West Bengal, I know the political and economic scenario. Let us not talk about that. I think aerospace engineering would be a good option. First of all, there are a lot of jobs. You guys don't pay attention to jobs. You think that only doing physics will create a great impact. No. First of all, you also have to think about jobs. You have to also think about money. You have to think of supporting your old parents and get your money done. Okay, astrophysics. No, in that case, I would say go for aerospace engineering. Uh, why? Maybe it is a little bit. I will tell you later, Indrajit. Get in touch with me personally. Astrophysics is something which would require a lot of, I would say, you need to go out of India if you're really good on that to study astrophysics. See, I will tell you this Professor Anindo Dotto, he's from West Bengal, who is coming down on 19th. Do you know that? He's from West Bengal, right? Now, only because he studied astrophysics, why no? He went to NASA. He went to NASA and he did his PhD from TIFR, Tata Institute of Fundamental Research, Mumbai. Are you listening to me, Indrajit? I hope you are. I'm not hurting you. Don't take me wrong. I'm saying you the practical thing. So until you make up a mind through your scholarship and your money, whatever the money that you have, buying the air tickets, etc., you can really go out of India then only you can become a good astrophysics, because astrophysics is too much of an experimental physics rather than cosmological theoretical physics. Whereas if I take aerospace engineering, okay, aerospace engineering is much more applicable, jobs are there, money is there, establishment is there. Okay, don't take me wrong. Again, Indrajit, I'm not disregarding you, or I'm not underestimating you. What I'm telling is that aerospace engineering has got lot of other options, lot of establishments, and lot of, I would say, job and application rather than astrophysics, my dear son. Because astrophysics, again, I would say you need to go out of India, because to be very honest, I have been around countries, don't take me wrong. In India it is not possible. I'm not saying, Prasad, it is not possible, but in India what happens, compared to other countries, we really lack in terms of space science. I mean to say, instruments are not that very good. So that is why you see, when I was talking to, yeah, so I was talking to Dr. Iqbal from Oxford, who came in, you remember, in regarding nuclear physics. So what he told, that Shounak, people in India are very good in mathematics. Why? Because the mathematical brain of India is better. Why? Because there is no experimental science in India. Why? Because India lacks in terms of telescopes, etc. Okay, got it. So I would say go for aerospace. And don't mind that aerospace engineering does not mean that you won't be able to do cosmology or astrophysics. You never know. At my age, certainly you can shift from aerospace to, what you call astrophysics, because all roads lead to Rome. When I was at Ramakrishna Mission, we were taught one line which Swami Vivekananda told, that Nirnam eko gamyastvamasi payasamarana vaiva. Nirnam eko means nar. Nirnam, Sanskrit means human beings all travel to one destination. Nirnam eko tvamasi payasam arnav. Arnav means what? Arnav means ocean. Right. So all those things, as they merge in ocean, human beings are going to the same God. Whether you go in cosmology, astrophysics, doesn't matter. Got my point, Indrajit? So you do take up aerospace engineering. That would be much better. And keep in mind your astrophysics dream. In later part, you will definitely get into astrophysics. I can promise you. You take my word, today on 10th of November. I'm so sure about it, because I have seen many students. I have seen many lives. I have seen myself also. Okay, Indrajit, are you happy? Wish you a very happy Diwali. Somebody wished me a happy Diwali. Just a second. Oh, Faisal Azmi. Okay, Faisal Azmi. Hello, sir. Happy Diwali. Happy Diwali, Faisal. Wish you all the best. Diwali should be soundless and very safe. We should not create no more of pollution. Arise, Aries Nainital is also good, sir. Yes, Nainital is very good. Yes. Okay. Somebody asked me, sir, all math. Okay, this is Mark. This is Mark. Okay, all math, sir, all math can be compressed to geometry and algebra in a way. So, what is your thought about this? Even calculus is just an extension of algebra if you think about it. Yeah, exactly, Mark. I was just telling about this. I mean to say, until we really find the theory of everything, it is all with one thing related to other. Someday somebody, don't take me wrong, somebody criticized over this YouTube channel, that they were telling that you make videos on general relativity, you make, sir, videos on quantum mechanics, again you make video on quantum field theory. See, the problem is not that I make so many videos, that means he is telling I don't know anything. That is fine. I mean to say, I admit that. But the problem is that you need to understand, Mark, everything is related to other. Now, when I read general theory of relativity, it is not that I cannot know quantum mechanics. If I'm good in quantum mechanics, why won't I make videos? Because if I am convinced that here is something which I can make it beautiful, quantum field theory is so complex, people run away from there. Now, if I, Shaunak, is confident that my dear Mark, dear Faisal, dear Indrajit, dear Prasad, wait around here, I will make a series of videos where I will teach you quantum field theory. It is free of cost. Then what is the problem? I mean to say, what is the problem with the people if I can teach? And you can verify my teachings with anybody else, that whether I might make mistake in equations. I always admit, and I pin it in the comment. So the thing is that if everything can be compressed to geometry and algebra in a way, so everything actually has to have one single theory, one single idea. We are not have yet found it. That is the problem. We are still in search. Right? Okay. Okay. What is the next question? There are a lot of questions. We have a great telescope. Yes, in Nainital, I know there is a great telescope. I have not never been there, but it is very good. Arnav means the fluid that can be described as a single wave function, ribose Einstein condensate. Yeah, I mean to say we were taught Sanskrit very well in Ramakrishna Mission. So Arnav actually means the ocean. Okay. Okay, so fine. Okay, so these are the questions. Anything more? It is good to see a lot of people. So what I would say, well, what do you suggest? All the people who are listening to me, shall I make a YouTube live every day on different subjects teaching the mathematics, or shall I come online to ask or answer your questions? I mean to say, what would your opinion? Can you please put it in the comment box? See, I am making a series of videos every day teaching the quantum field theory. I think I will also make a series of videos live, and live is good because when I am teaching, you can ask me questions. But I really don't take me wrong. I really find one or two people coming online. Maybe people are not interested in the mathematical part. Please explain Lorentz gauge used in GR briefly. Okay, now this is again, it will take some time because Lorentz gauge, in terms of general theory of relativity, you want to go mathematically or just want to get a basic idea of what is Lorentz gauge? Because see, Lorentz gauge in general theory of relativity is basically, it is also known as, as the harmonic gauge. So what happens typically is it is a specific gauge. I'm so sorry. It is a gauge condition in the context of the relativity, which is a theory of gravity, which is described by Albert Einstein. So in general relativity, what happens? There is a metric tensor which describes the curvature of space-time, and the Einstein field equations actually provides the framework for solving this. Now, Lorentz gauge, if I want to denote that, actually, I need to show it actually is the nabla f, yeah, g equals to 0. So it is difficult. I mean to say, you can fix Sunday for talks. Yeah, that is a very good, very good suggestion. No, see, I mean to say Zoom meeting interactive sessions. Huh, Zoom, actually, I don't have an account. I need to create it again. No, what I'm asking you all, my dear friends, I mean to say sons and sisters and brothers, I mean to say, if I make up a series of videos teaching the mathematics of general relativity one day, teaching quantum mechanics, teaching quantum field theory, teaching real analysis, I mean to say each day one particular area, then do you think that people, I mean to say, I just want your suggestion because it is you who are means a lot. I mean, so everything for my channel and everything. So do you think that this type of lessons, dealing the mathematics, doing the exercises, asking questions, etc., will that be okay? Say for example, one day in calculus, one day in real analysis, one day in quantum wave function, what is a wave function? Or do you think general discussions where I can clear up confusions one by one, will it uh, make a sense? What do you think? Today live, but take live, but take in weekends. Oh, okay, okay. Because every day it will be hard to join. Okay, yeah, that is a good question. That is a good suggestion. So Indrajit, you are telling I should make it Friday. Today is what? Today is Friday. Okay, so Friday, Saturday, Sunday, I think it is better. What you're telling. Vikram Vishal, I will kill you. This is my favorite topic. One day from for philosophical interpretation only. Very good. So Vikram, you have to tell me what philosophical interpretation, because I'm lot into philosophy and mathematics. This is a very good thing. No, sir, make continue video on the topic, otherwise it will be less helpful. No, actually, see what happens in when I'm making a video, it is more or less I have to mix match, right? Because video is going to be watched from class 12 to PhD. But what I was willing is that if I make it on a lesson, I mean to say YouTube, sorry, yeah, a daily live video, then I can actually deal more with the mathematics. I mean to say take down by the mathematics. But I will take Indrajit's suggestion. This is very, Prasad is also telling Saturday or Sunday. ठीक है? Okay. You let me know. I mean to say, do you want a discussion or do you want, I would say, a complete study? Anything you can tell. I mean to say, I'm okay with that. If you want a study, then I can make a complete syllabus teaching real analysis for 50 classes, teaching quantum field theory 50 classes. I know that maybe I am a very small sub YouTuber, so people really don't know that I come online and I teach. That is also true. That is why people are not aware. But today, you see, I've got more participation because I'm answering to the question. Fine, we will do that. Then, yes, discussions too. Okay. And what we will also do is that from next time onwards, I will try to create books. Let us take up books. Okay, Prasad is very much willing to study. Prasad, you are the only one who wants to study. Rest of them don't want to study. Okay, Indrajit is telling take a topic and start from beginning. That is actually Indrajit. Indrajit is telling the right thing. I am also thinking of that. Let me take up a topic and start from the beginning. Complete study and Saturday Sunday discussion because hard topics are not available. Hmm. No, I will tell you very honestly. Let me be very honest today. You, I'm sitting at home. I will be Karan Nanwar. Namaskar, sir. Namaskar. Namaskar, Karan. So to be very honest with you, I will tell you, don't take me wrong, okay? Don't blame that Shounak sir is boasting or he has got a lot of ahankar. But what I am telling you, every day when I am studying more quantum field theory, etc. Okay, Shubhasri Bhattacharya. Good evening, sir. Good evening, ma'am. I hope you are fine. So make it interactive. So what is happening is that this particular subject, quantum field theory, every day when I'm learning and interacting with the professors, I am actually getting a bigger picture. I'm actually getting a bigger picture. Bigger picture, not in terms of mathematics. I am trying to make the mathematics simple, bit sized, easy. Now, yeah, Prasad is also telling us, sir, I agree with Indrajit Das. Now, see, for example, let me give you a small example. We all know that we need quantum field theory for ABCD reason. Now, the question is that do you really know what was the problem with classical mechanics that resulted in quantum field theory? What was the problem? What was the basic problem of classical physics that resulted into quantum field theory? That is the thing which I'm trying to explain. Spontaneous emission. Schrodinger equation is a classical equation. Kinetic energy minus total, the plus total kinetic energy and potential energy. I am actually showing with simple equation that, see, boss, this is the limitation of Schrodinger equation which led to quantum field theory. So my question to all Vikram, Vishal, Prasad and Rakesh and everything who are watching this live is that I am trying to go deep into the mathematics, deep into classical physics, and then I want to make you understand that until you understand the limitation, how can you understand quantum field theory? How can you understand general theory of relativity? So those who have already, Indrajit, I think you have attended my general theory of relativity webinar. Now I am trying to improve this month. This month also I am holding the general relativity. I'm from this January 2024. I will make my this general relativity a little bit more advanced in terms of differential geometry. So what Indrajit is also telling that I am trying to give a different kind of a perspective of physics and these theories. Now I cannot do it in videos because the videos will be too big. I am known that I make big videos. That is not a problem. You have supported me. You watch all big videos. But in live classes, I want to draw those equations and teach. And then you can say, sir, I cannot understand this integration. That is my purpose of coming down to there. So that's it. Okay. Samidha, physicist. I think I have never talked to you. Sir, how a physics win Nobel Prize? I mean the okay. Okay, fine. Okay, this is a very good question. Samidha, I mean to say, where are you from? Which part of the country? Faisal also have a good question. Okay, let me tell you. How does a physicist win a Nobel Prize? It's a good question. I was watching an Instagram video where that lady was speaking. See, the thing is that any kind of a Nobel Prize, first of all, in physics, has to be experimentally proved. Number one criteria. You see, that is why Stephen Hawking never got the Nobel Prize because his Hawking radiation is such extreme that he never got something which is experimentally provable. Roger Penrose hypothesized the geometrical construction of black hole much earlier. Do you agree with me? Much earlier to Reinhard Genzel and Andrea Ghez. But why he was not received the Nobel Prize? Because we have not been able to see the supermassive black hole. Because the star has to go around on a specific day in 2018-19 May, and then only we will see the gravitational redshift. Are you getting my point? So this is number one criteria, that it has to be experimentally provable. And that is why you so mathematics has not got a Nobel Prize, just got a Fields Prize. Why? Because everything in mathematics is not provable. I mean to say, you cannot see it experimentally. And obviously the idea has to be original. First of all, it is idea to be original. I would say Samidha, I say there is a book, if you have read, it is called The Prize, written by, wait, The Prize book. Uh, uh, who was that author? Irving Wallace. Irving Wallace. If you read this book, it's a literary book. Okay, that actually explains the lot of problems, politics, undercurrents which happens in Nobel Prize. Again, I repeat, Irving Wallace, The Prize. Old book. Irving Wallace has got a lot of good books. So, Samidha, I would request you, if you're listening to me, please read this book, uh, Irving Wallace, The Prize. It will be a good book. Okay, so you got your answer. Okay, what is Faisal, my dear son, is telling? The book by Tristan Needham, he recommends five must-have books. One of these is Elementary Differential. Ha ha ha. Yes, Faisal. Absolutely, you're right. I read this book, Darian O'Neill. Yeah, different elementary differential geometry. Yes, you should go ahead. Tristan Needham's book, one thing is that it has got a lot of graphs, Faisal. It is easy to understand, but I really do not recommend Tristan Needham's topology. It is, I mean to say, I read it. It is very haphazard. I mean, I mean to say, it is starting with homeomorphism. I don't know. I mean to say, complex analysis, other books are good. But yes, what you have told, I wholeheartedly agree. Faisal, if you're listening to me, you should go with, I think I have suggested in my differential geometry book, right? Darian O'Neill's or something. Yeah, it is a very good book. Okay. So Rakesh is telling what? Why is Lagrangian not conserved but Hamiltonian is conserved? Physics intuition, please. Why is Lagrangian conserved? So, in which area you need to tell me? Which area? I mean to say, are you talking of quantum field theory? You have to let me know that, because this is a very generic question. See, in classical mechanics, the Lagrangian and Hamiltonian are basically two ways, because the Lagrangian is actually the generalized coordinates and their time derivatives, for example, qt, etc. So the equations of motion of the system are actually derived from Euler-Lagrange equations. And Hamiltonian, say for example h, which we do denote, is a function of generalized coordinates of their conjugate momenta. So the Hamiltonian equations of motion actually do not naturally lead to the conservation of the Hamiltonian itself, right? However, if you take a kind of a, say, for example, this room, which is a closed conservative system, the total energy, which is the Hamiltonian H, can be conserved. And that is why it is a consequence of Noether's theorem. Okay. Okay, in class, okay. Basic books of general theory of relativity, Ankan Jana. Barrett O'Neill. Yes. Faisal. Barrett O'Neill. It was not coming. Okay, basics book of general theory of relativity, Ankan Jana. First of all, I would like to tell you there is no basic book of general theory of relativity, to be very honest, after reading so many years. First thing is that my question, Ankon, is that um, uh, which level of general, I mean to say, which level of general theory of relativity you want to learn? Is it, for example, you want to learn general theory of relativity taking the geometric point of view or the mathematical point of view? Because I would always suggest that general theory of relativity should be started with differential geometry. You go to my playlist on how to learn general theory of relativity, differential geometry, there are certain books. I would recommend, if you're talking of a textbook, you can either go for this one, Gravity by James Hartley, and second one would be, I was reading that book, what is the name? Space-time geometry by, uh, just hold on. What is the name? If somebody remembers, very famous, that red-covered book, Space-time geometry. Sean Carroll. Sean Carroll. Oh, you're doing MSc. Then I would say, Ankan, first of all, don't go for Sean. Scene is Sean Carroll. Okay, I might have pronounced it wrong. Wait. I will give you the link. Just a second. Just a second. Hold on. Uh, General. Am I going old or what? I'm forgetting the names of these books nowadays. I don't know what is wrong with me. Maybe I'm getting, one day I could not recognize a very old friend of mine on the street. He was telling Shounak, but I won't be able to. And maybe. Okay, this is the link. Go for this book, Ankan. This is absolutely wonderful right from the beginning. If you're an MSc student, you should go for this. But I would also request you, please go for this one, what you call differential geometry. Without that, please don't jump into general theory of relativity. But this book is a gold. This is my golden book. Okay. Why we use Hamiltonian in quantum mechanics, not Lagrangian? Okay, very good question. This is a golden question. Wait. Ankan, I will tell you, just a second. Where is it? I just made it. Just a second, be on there. I know you guys are busy students. Uh, where is that gone? Just a second. So video of mine. Just a second. I'll just give it to you. Hmm. This one. I won't give this long answer. And if you really want to learn, Ankan, I'm giving this link to you. Please go through this. This would be the answer to your question. Why we use Hamiltonian in mechanics, in quantum mechanics, but not Lagrangian? Very good question. And you can get the answer over here. Okay, just to tell you in a brief why it is the Hamiltonian, not the Lagrangian in quantum mechanics. See what happens, I will be very precise in understanding. We actually, both the Lagrangian and Hamiltonian actually can be used to describe a system. Okay. Now, the problem is that why Hamiltonian is preferred. I would say it is preferred. It is not that we cannot answer. Okay. Why it is that we prefer it? First of all, is that Hamiltonian formulation, you understand, in quantum mechanics, typically leads to very much more simpler mathematical expressions, because quantum mechanical operators are now equations of motion. As I told you, I cannot explain it so easily. So quantum mechanical operators now become equations of motion. So that is why, that is number one. Second thing is that the Hamiltonian operator, that's H with a hat, right? Hamiltonian operator actually corresponds to the total energy operator in quantum mechanics. So the operator represents what we call is the observable energy of the system. And that is why it plays a very simple role in quantum mechanics, because the Schrodinger equation, if you take, right, it is the time dependent equation. So many quantum mechanical properties, I would say, and observables that derive from the Hamiltonian operator. Another thing, that is why I always tell, have an understanding of what is called the history of quantum mechanics. Transition, if I take the left hand side to be the classical mechanics and right hand side. So the transition from classical mechanics to quantum mechanics is more, I would say easy. It becomes straightforward in Hamiltonian formation. So the classical variables, say for example, position, momentum, whatever, have are basically natural, I would say, quantum operators in the Hamiltonian formation, which is not there in Lagrangian. So, for example, if I take, say, for example, QP, okay, Q comma P is equal to reduced Planck's constant, H bar. So, what happens is that in terms of momentum operators, they don't commute, as you know, in quantum mechanics. And this is easily incorporated in Hamiltonian formulation, because this non-commutation is not a feature of Lagrangian. Okay. And also the wave function, that psi, okay, that this is one. The wave function is also a fundamental concept in quantum mechanics. Everything is defined by wave function, right? So it can be easily expressed, and we can change everything using an Hamiltonian operator rather than Lagrangian. Because understand, the Lagrangian by itself, I mean to say, philosophically, Lagrangian is classical. Lagrangian is actually classical, where the Euler-Lagrange equation can be derived from Newton's equation can be derived from Euler-Lagrange equation. So how we can use Hamiltonian in terms of Euler-Lagrange equation? It is difficult. You got my point, Ankan? Is Ankan asking the question? Yeah. So this is one point. Another thing is that, so the Schrodinger equation, if we take, which actually is the father of the wave function, it is typically written in Hamiltonian H. You get that, right? So what I can tell, that Hamiltonian formulation is commonly used. It is important because Lagrangian formulation of quantum mechanics is also applicable. But in some cases, particularly when dealing with, say, Noether's theorem, symmetries, etc., the Lagrangian formulation can sometimes be used in simplification. So ultimately, what you can say, Ankan, the choice whether you will use Lagrangian and Hamiltonian formulation quantum mechanics depends on the problem, what type of problem, and the mathematical tools that are most convenient. So both formulations are okay. Both of them are consistent. We got both of them. But the question is that quantum mechanics can be used to describe the same physical phenomena depending upon the situation that is given to you. Ankan, you got my point. I gave a lecture. Okay. So it is almost an hour. There is a concept, but Feynman path, a Feynman integral path to minimize the path uses the action over Hamiltonian. Yeah, Feynman integral path uses the path over Hamiltonian. That is what I was telling to Ankan, that it depends that whether if you're taking a path integral formulation of point A and point B, and look at taking all these paths, then definitely this will come to useful. But Ankan's question was different. Ankan was asking that why Hamiltonian is preferred over Lagrangian. So both the formulations are okay depending upon what you do. So Ankan has got it. Okay. So I think what shall we conclude today's session? Stay homes. Sir, what was Einstein thinking when he used this code? As far as laws of mathematics refer to reality, or they're not certain. So this is a philosophical quotation. Uh, the law, as far as laws of mathematics refer to reality, they are not certain. But as far as they are certain that they do not refer to reality. Yeah, actually, this is basically again that God does not play dice kind of a funda. So when you are taking the laws of mathematics, say for example an algebraic law, and you try to refer to reality, reality is again something different. That kept Einstein bothered till the day he died, because when he is applying the quantum superposition, etc., it is not matching with the reality, because he is, today we are not loving you, sir, we have lots of questions. We are not leaving you, sir, we have lot of questions. Okay, so shall I take the dinner with you all? Okay, that's fantastic. Okay, so what yeah, Animesh, you can ask me the question, but let me answer Mark's question. So the thing is that this is something we really need to think, that as far as the laws of mathematics refer to reality, that means if I take classical mechanics, because Einstein is a classical person, when he used these classical mechanics, when it is reflecting to reality, it is not matching. Which reality? Quantum reality, right, Mark? It is not referring to the classical reality. So as far as the laws of mathematics refer to reality, that means reality means what? The quantum reality is not matching. They are not certain. Certain means what? Deterministic. Got it? And as far as they are certain, they do not refer to reality. Yes, as far as they are certain, that means if I am able to see an electron and I'm trying to find out the position and momentum, they do not refer to reality. Reality means the mathematical reality. So if I'm using classical mechanics to understand the quantum reality, it is not matching. But as soon as I observe the quantum reality and I'm trying to do it with mathematical reality, it is not matching. So, I don't know whether you will agree to me. It was Werner Heisenberg. I will tell you a small story. He came to India and he asked, when he met with Tagore, Rabindranath Tagore, I hope you are all aware. So Tagore was telling, he was explaining Schrodinger's equation to this one, Rabindranath Tagore, that Heisenberg's uncertainty principle, this, that, position, momentum, etc. So as I told you, somebody told me what Vikram Vishal, that physics and philosophy. So he was telling that, this is the way uncertainty principle happened. And Tagore told a line I remember when I was with Ramakrishna Mission. This was taught during the first years of our Vedic classes. That is called Ishavasya Upanishad. Okay, so what was Ishavasya Upanishad? Tadei jati tannei jati tad dure tadvantike. Then there is tadantaras tataras. So tat ejati. Ajas means what? Ajas means vibration. Tat means that. Again, I'm not teaching you Sanskrit, just to tell you from my experience what Mark actually told. Tat tadejati tannejati. Tat ejati tat na ejati. That means what is vibration is not a vibration. String theory in some way. Tat ejati tannejati tat dure tat avantike. That which is far is again very near. Are you getting my point? So the same Heisenberg's principle used in terms of Vedic quotes. Tat ejati tannei jati tat dure tadvantike. So Ishavasya Upanishad is also talking of Heisenberg's uncertainty principle in a different way. Okay. Karan is asking, how was your experience with pure mathematics? Karan, my experience with pure mathematics is absolutely blissful, soulful, and spiritual. I can tell you, Karan, this much. The amount of peace that I gain when I learn or I do or I break my head understanding pure mathematics, I never get it anywhere else. So my experience in pure mathematics is tremendous. It is absolutely blissful. Okay. Animesh, I have asked you regarding Stewart calculus book above. Where have you asked? Sir, my last question. Animesh Shah. Animesh, can you just tell me what is your question once more? Uh, Sir, please make a separate video on divergence theorem used in GR for four-dimensional space. Okay, exploring that. Yeah, that is on the process. If you watch my series of videos which are coming up, I will be making that. Don't worry. I am waiting for Animesh's question. Stewart's calculus book. Let me just check. I think I have a Stewart calculus book. So if you ask me the question once more, I will be happy, Animesh. Stewart's calculus book. Oh, James Stewart calculus. Okay, okay, okay. I was saying it's Stewart's calculus with James Stewart. Uh, what I would say, it's a good book, definitely above that. Okay, let me see. Missing something. Animesh. Uh, so, Animesh, okay, new comments. Animesh, you want to ask me my opinion about the this Stewart's calculus book? I would say it's okay. I have, it is nothing. So right below your link. Wait, where is my link? I forgot. So are you asking basically my opinion about this book? It is okay. I mean to say nothing. Nothing extraordinary about this book. It is good. I mean to say, yes, you can definitely try ahead. Okay, Anant Badal is asking what are Majorana for, okay, and what is a good source for beginners to start about Majorana particles? Okay, so again to explain on a very easy matter, these are actually is a type of particles that are their own antiparticles. Particles which are by their own antiparticles. That means that they are identical in terms of their antiparticles. So say for example, if I take a typical fermion, which includes, say for example, electrons and quarks, etc., Majorana fermions, they don't have any distinct antiparticles. They are themselves their antiparticles. Majorana fermions actually, uh, I would say, they actually found out, I think it was who, Ettore Majorana or somebody, yeah, who find it out. So it is basically, if you want to start reading Majorana fermions, I would say try, learning condensed matter physics, which I am very much not aware. I will be very honest with you. It is not that I know everything. So because these are associated with, what is called quasi particles, so they can emerge in between materials. So that is why condensed matter is important. For example, superconductors, or what is called topological insulators, etc. So these so-called superconductors actually can host Majorana particles. So I really don't know the name of any book. If you give me a little bit of time, then I can let you know, Anant, and you can contact me over my email. I would definitely take these things out. Okay, now, no, what is the difference between traditional calculus and Stewart book versus mathematical method by both books? Okay, see, as far as the traditional calculus is concerned, I always say it is better that you read traditional calculus. That would be the first, I would say, first step forward. Now, traditional calculus, I really cannot understand. Difference means uh, this is more of an, I would say, a application based calculus book. This is one part, and Boa's book, I have not read it. So uh, I would say Stewart's calculus book is basically a very, I would say, comprehensive, and the clarity in terms of explaining concepts are very clear, and it is a very popular book, I mean to say. Also, Michael Spivak's book, you can try it out. So traditional calculus book means that would start right from the very basic. Stewart's calculus book would take a little bit of assumptions on the say. That's how it is. Okay, so thank you all very much for today's session. So as you have requested, I will try to come. Tomorrow is Saturday. I don't think tomorrow would be possible. Let me see, because all of you want between Saturday and Sunday. There are certain questions which I also have not been able to understand or been able to answer you correctly in this session. So I would request all of you that please write to me in my email. I always reply to my emails. So emails would be the best way to do. And once you receive your email, I will instantly answer anything you want to learn regarding books, anything like that. So please do let me know, and I would help you out regarding books, etc. That would be good. Apart from that, that's it. So I think that really clears up. Okay, basic book for general theory of relativity. No, this is one difference in terms. Let's say for use in difference in terms of, let's say, for use in classical mechanics. Yeah, if you tell me in terms of classical mechanics, I think that it would be good to use the classical calculus books only. See, each of them are related to each other. You really cannot. Yeah, Karan has told the right thing. Yeah, yeah. Thomas and Finney is also a good book for calculus. I would say in our school days, I would say we learned what is called this is, Piskunov. I will type it out. This is also a Russian book. Piskunov. If you have read Piskunov, go for this book. Piskunov's book on calculus is also equally good. This is also equally a very good book for Piskunov. You can go, you can write to me, I will refer. Calculus, don't worry, there are a hell lot of books, huge amount of books which are there. Okay, so Animesh is saying thank you, sir. Thank you, sir. Indrajit is also saying thank you, sir. So thank you very much. So I really enjoyed this session. After a long time, we talked to each other, and I will keep on coming from time to time, as you have all said that weekends. I also understand weekdays every day is not possible. That is why I find less amount of participation, I also feel bored. But it is good that you all remember me, you all love me, and I also love you all, my boys and girls and brothers, sisters, seniors, whoever. So do keep supporting me. I will produce a lot of good videos. There are a lot of plans for 2024. General Theory of Relativity will have some special webinars also, which will upgrade you. I'm trying to register my certificate also with some good schools and colleges. I don't know how will be. So thank you. Oh, I will go through it. Okay. Karan Nanwat, good night. Thanks very much. So bye bye and take care. Thank you. Bye.